Okay, so we're going to be talking about solving radical functions. Yay! Okay, so to solve radical functions, it's a three-step process. We isolate the radical expression.
Oh, we can't see your screen. I don't know if we're supposed to.
Okay, so after we isolate the radical expression, you want to raise each side of the equation to the power equal to the index. So if it's cube root, power of 3, square root, power of 2. Solve, and then check for any extraneous solutions. All right? Okay, let's do one, and then we can revisit each of these points. So for this one here, you want to isolate the radical expression, right? So we're going to add 3 to both sides of this, making this 2x plus 3 equal to this. Then, because it's a square root, I need to raise this to the power of 2 on both sides. All right? We square the left side, and we get 4x squared. That's the first term. Okay, the middle term, which students always forget, is 2 times 3 times 2x, so 12x, plus 9. And that equals 28x plus 29, right? So now what I want to do is I want to move everything to the same side and solve. So I have 4x squared minus 28x on both sides. That will be negative 16x minus 29 minus 20 equal to 0. Okay? All right. I need to factor out a 4. You know what? Rather than factoring out and then I'm just going to divide everything by 4. So I'm going to get x squared minus 4x minus 5 is equal to 0. Factor x minus 5, x plus 1. And so finally, I get x equals negative 1 and x equals positive 5. Okay. Now, I need to check to see that each of these work. Okay. Why do we need to check? The reason is this. When I started out, I had a square root in my equation, right? That was my original equation. It was a square root. And we know that the domain of square roots is not all real numbers, right? Square roots only exist over half of the x-axis, right? Only where the the stuff inside is positive. Now, when you square, you make that condition go away. So what you end up doing is you might artificially introduce solutions which otherwise would not have existed, right? So now you have to check to see that both of them work. What we do is you take the first one. I'm going to take x equals negative 1. And you want to plug it into the equation in a step right before you squared. Okay, so let's plug it in here. When I have x equals negative 1, I say, okay, 2 times negative 1. Is this equal to the square root of 28 times negative 1 plus 29 minus 3, right? You want to make sure that the left and the right equal. So here you have negative 2. Is that equal to, what do we get here? Negative 28 plus 29 is 1 minus 3. Yes, those are equal. It works. Now let's do x equals negative 5. Same thing. 2 times negative 5. Is this equal to 28 times negative 5 in a square root plus 29 minus 3? Guess what, guys? They are equal. So both of these are solutions. Jacob, yes.
Why is it -5? Because in the problem you put
Oh,
5.
I'm sorry. I'm sorry. Yes, it's +5. But you know what? The +5 works as well.
Okay.
The -5 might not have worked. Okay?
Would it have also worked if you were to plug it in after we added the 3 to the other side?
Yes, that you could plug it in here as well. Any step before squaring is good.
Okay. So, like, is it better to just do the first step or better to do the one closest to when you squared it? Or does it not matter at all?
It doesn't matter. It's preference. Yeah. Okay. This next one, again, isolate the radical. So 4 equals cube root x minus 2 squared. Okay. Now I have a cube root. So I'm going to raise everything to the power of 3. Okay. 64 equals x minus 2 squared. Okay, here you have a choice. You can either square, bring everything to the same side, get a quadratic and solve, or you could just take a square root of both sides here, right? And you can get x minus 2 equals plus or minus 8. So x equals, when you add 2 plus or minus 8. So x equals 10 and -6. Okay, now, do we need to check for extraneous solutions in this case? Does this equation have that same situation where we started out with a root where the domain was not all reals? Let's look at the root, the original root here. It's a cube root. Yeah, Evan?
Oh, I was gonna answer it, but it's okay.
Tell me, what about a cube root?
I was gonna say not even the cube. I was gonna say because it's squared under the square root, it's not gonna be negative anyways. So it can be anything.
Exactly. And just exactly, yes, if it was a square and said the square root, it's positive anyway. And now we have a cube root, and anytime you have an odd root, the domain is all real numbers, so you don't have to check for extraneous solutions, okay? Odd root, no need to check. Okay, last but not least, here we have an equation with 2 roots, okay? When you have this situation, you know how the first step was to isolate the radical expression? Well, there is no way to isolate because no matter where, you know, that one is going to be with one of the radicals. What you want to do at least is make sure to only have.
Wait a minute, just to be clear, even though there was an even thing, because the root itself, the cube root itself was odd, there's no need to check, right?
Precisely, it's because of the cube root. So make sure to only have one radical on each side, right? So sometimes you might have, you know, root blah, 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 plus root blah, blah, blah equals 1. Rearrange it so you only have one root. Mathematically, it doesn't make a difference, but computationally, it just makes things a little bit simpler. Okay. Okay, here we go. We're going to square both sides. Okay, we're going to square the entire thing. Okay. All right, when I square the left-hand side, I just get x plus 1 equal to. Now I'm going to square the right-hand side. This is a plus b squared. So I'm going to get 3 terms when I square, right? So what I do is this. Square the first term, you get 1. Now, the middle term is going to be plus 2 times the root times the 1. So 2 root 2x minus 12 plus square the last term, 2x minus 12. if you forgot or are unsure of how that squaring works, we can get together one-on-one later and I can go through it with you.
Oh,
So
it's just
now,
a squared plus 2ab equals b
plus
squared.
b-
Pretty much what this is, right?
yeah, a squared plus 2ab plus b squared.
B squared, yeah, exactly. The whole
Yeah.
square root is the b, but yeah. Okay,
Precisely.
got it.
Yeah. So now what I'm going to do is move all of the non-root terms to the left side, right? So subtract 2x, so I get negative x plus, let's see, I'm going to add 12, and okay, so here I have the negative 12 and the positive 1, bring it here, so I get positive 12 equal to this. Okay? So look, if the negative x plus 12, we hate those dangling negatives. If that bothers you, you can always switch it to get 12 minus x. It's up to you, okay? All right, I'm going to leave it like this for now. All right, now look at what happened. I still have a root. So what do you guys think we should do? Square both sides again.
Can you divide by 2 first?
You can if you want to. The reason why I don't is because even though 12 divides by 2 evenly, here you'll get an equation, a fraction, and then I don't want to deal with fractions. So I would rather square and then divide. Okay, so when I square, I get x squared minus 24x plus 144 equal to 4 times 2x minus 12. All right, so when I distribute the 4, I get 8x minus 48. Okay, now I get x squared, subtract the 8x, minus 32x, plus 192. Equal to 0, right? Which means we have to factor this lovely equation here, right? What gives you 32 and 192? Well, negative 24 and negative 8. Okay. How do you do this? You can either do it by trial and error, or if the numbers get really large, like there is one problem in the homework that gets really large, what you can also do is, this is a quadratic equation, right? Just plug it into your calculator, right? Because you need to show the work, right? Just plug it into your calculator, get the parabola, and see where it crosses the x-axis. You could also do it that way. Evan.
Could we also just do the quadratic equation?
You can do that as well. Absolutely. The
Yeah, I was
quadratic
about to
formula.
ask that quadratic form.
Absolutely. You can factor by completing the square. I mean, you guys have learned so much. Any of them are fair game. So now x is 24 and x is 8, potentially. Do we have to check answers for this problem? We do. All right, so let's check x equals 24 first. I'm going to plug it into that first step, right? So I get root 24 plus 1 is 25, right? And then I say, is this equal to 1 plus 2 times 24 minus 12? And so this is 5. Is it equal to 1 plus 48 minus 12 is 36. So it's not, right? So that doesn't work. And there might be different reasons why it doesn't work. You might get a negative instead of the root. That doesn't work, whatever the reason is. Then we plug in x equals 8. And we're going to get root 9, which is 3. And then on this side, 1 plus 16 minus 12. 3 equals 1 plus, this is root 4, 2. Oh my God, it does work. So x equals 8 is the only one that works. Yay. Okay? Okay.
How'd you know? Wait, how'd you know you had to check for this one?
Because in the beginning, I had in here my original equation, I had square roots. Anytime you have even indexes, square root, fourth root, you have to check.
Oh my God, in my head, oh my God, I'm such an idiot.